Okay, today we're going to be looking at some design problems, and usually design problems are you're trying to either maximize or minimize something. Maximize your profit, minimize the material, different things like that make a design problem. So in our first example, it says you want to make a cylindrical candle using exactly 100 cubic centimeters of wax. You want the candle's height to be equal to its diameter. So that's very important information there, that the height and the diameter are equal to one another. It asks us what radius and height should the candle have. So in part A, it says let the radius of the candle be R. So it's telling us what variable to use, and let the height of the candle be H. So the diameter of the candle, we want to use these two variables in the problem that we're given. It says the diameter of a candle would be what? Well, we don't want to put D here because that introduces a new variable. Well, we know that it takes 2 radii to make up the length of the diameter. So if R is the radius, then 2R is our diameter because it's twice as long as the radius. Since the height is equal to the diameter, then we know that H also has to be whatever the diameter is, which is this 2R. So H is also 2R. So here we have the volume of V. We already know that formula, the base area times the height. And we're going to substitute in our values here really we don't have to substitute anything for M for radius because we know it's just R, but the H we're going to replace with the 2R and give our simplified version of the volume. So the radius squared is still R squared, but we're replacing the height with 2R. So remember on the true-false questions I said don't leave your answers like this. Make sure your answer is simplified. So the coefficient, this is all just multiplication, the coefficient I'm going to move to the front, and since I have an R squared and an R, which is an R to the first power, remember when you multiply two numbers with the same base, you add their exponents. So I'm going to put my 2 in front, then my pi, and then my R will be to the third power. So that is the simplified version of the volume of this cylinder. Now let's move on to part B. It says use the fact that the volume of the candle is 100 cubic centimeters to write an equation that has R as its only variable. Well, we just wrote a version of the volume that only had R as its variable. We had volume equals 2 pi R cubed. But now since we're given the volume, remember that's why I say it's always important to write your formulas as equations. There's two sides, and this is the reason that that's important. So now the 100 goes in for the V. So our equation is 100 equals 2 pi R cubed. So to solve for, remember we're trying to find the radius and height that the candle should have. To solve the equation, we're going to use our graphing calculator. So the first thing your instructions say is on your y equals to enter the left side of the equation as y1, where our left side of the equation is 100. So on my y1, I'm going to put in 100. Then we're going to enter the right side of the equation as y2. So I'm going to put the 2 pi, and then we don't have an R for the variable, we'll just use x, and we're raising that to the third power. So I have my 100 on the left side and 2 pi x to the third power as the right side in the second equation. You're going to graph the equations, but it says be sure to choose a viewing window in which you can see the intersection of the two graphs. So I've given you your viewing window here, and I want you to understand why I chose the numbers that I did. Remember the x, which is really representing our radius. Radii of cylinders can't be a negative number, so I chose my x min as 0 since radius can't be a negative number. I chose the x max as 10. If that didn't work, I could always go back and make that bigger. Now the y is the answer when you do your 2 pi R cubed. And so I did the y as 0 to 150 just to make sure that I covered that 100 and saw beyond that. Okay, so here's the y equals 100. Of course, that's going to be a horizontal line. So this is what our graph is going to look like. So to change your window, go to Window, the second gray button here. We're going to change our x min to 0. keep our X max as 10. The scale you always want to keep as 1 typically. The Y, again, our volume can't be negative, so we're going to make that 0, and we're going to go up to 150 just to get a good view of the intersection of these two graphs. So here's what your graph should look like, which is the pictures on your notes there. Here's the Y equals 100, the horizontal line, and here's that part of the cubic function that the 2 pi r cubed represents. Remember, a cubic function is an S-shaped graph. This is just part of that S-shaped graph. So we have graphed the equations, we chose our viewing window, then we're going to find the intersection. So if you've forgotten how to do that from Algebra 1, to find the point of intersection, you want to go to the Calc menu, which is in blue above your trace. So you're going to hit second trace to get to the Calc menu, and number 5 is how you find an intersection. So you're just going to press number 5. Now it's going to ask you questions, first curve, second curve. You're just going to press, you see how it's on this line and it tells me that's my first equation. So it's correct, that's the first curve, so you're just going to press enter. And now I really can't see my cursor, I don't know really where it is, but if you'll look up here, it has that second equation there. So I know it's on the second curve, so I can just press enter, and we don't ever guess, so I just press enter there too. So you really just press enter 3 times, and it's giving us our intersection. Now the X coordinate of the intersection, remember the X represents my R in my equation. So the X coordinate is the solution to the equation. It tells me my radius. Okay, and we're going to round to the nearest tenth would be fine. So the tenth position, there's a 5, next door there's a 1, so we'll leave that as a 5. So the radius of the candle, which is my X value, is approximately 2.5. And since my volume is cubic centimeters, I know the radius is just linear centimeters. So now we can find the height. So remember, the height is equal to the diameter, not to the radius. But if the radius is 2.5 centimeters, then I can double that, and the approximate diameter would be 5, which means my height is the same as the diameter. It would be 5 centimeters. Now, how can I check to make sure my answer is reasonable? I can go back to my volume formula. Volume equals 2 pi r cubed. I know the volume I want is 100. I can put in that value for the radius of 2.5 to make sure that that's a reasonable answer. So if I go in my calculator and I multiply 2 times pi times, I'll just put it in parentheses, the 2.5 to the third power, then I get 98.174 blah blah blah. Now that's not exactly 100 because remember that's not an exact radius. So, but that's pretty close. 100 and 98.17, those are pretty close. So that's what you want to make sure that those are close. If it was way off, you would obviously know you've done something wrong. All right, so that's example 1. Now when you get to your problems, number 1 on your homework tonight is very much like that, except you have 5 cubic centimeters of clay instead of 100 cubic centimeters of wax. Instead of your height and diameter being congruent to each other or equal to each other, you're told the height is 3 times the radius, so you have a different relationship. You're going to go through the same process to find radius and height. So refer to example 1 for problem number 1. The rounding instructions are not given, so just like in the example, round to the nearest tenth, but remember, don't do that till the end. We didn't do that until we got right here. So you never round along the way, wait until the end of the problem. All right, so let's look at our second example. It says you want to build a storage box from a piece of plywood that is 4 feet by 8 feet. You must use 6 pieces. 1, 2, 3, 4, 5, 6 pieces for the top, the bottom, and then the sides. Okay? So you must make cuts that are parallel and perpendicular to the edges of the plywood. So we're making a rectangular prism or maybe a square prism. And we're going to describe 3 different possible designs and what we think would be the maximum possible volume for our box. So from the figure, it says consider the design here. The top, bottom, front, and back of the box are all congruent rectangles. The ends are squares. So notice how the dimensions of the square are both x. That means that the dimensions of those sides have to be exactly the same. The gray piece is your waste. Now, when you're making something in the design world, you want as least amount of waste as possible. So we don't want very much waste. If you look at the figure, you can see that 4x, right here, we have 4 x's, and it tells us that is 4 feet. So we can write this equation as 4x equals 4 feet. Which means we can solve for x by dividing both sides by 4 and find out that x equals 1 foot. Now here it says 8 minus x equals how many feet? Well, right here it tells us that 8 minus x is this length. Now this is also part of this 8 feet, so don't say that 8 minus x equals 8, okay? This x is part of that whole 8 feet. We already know what x is. If this is 1 foot, then we have 8 minus 1 left for the 8 minus x part. Make sense? 1 plus 7 gives me 8. So this 8 minus x equals 7 feet. So now I can find the volume of this box. My length and my width of my base are both 1. My height of my box would be this length right here, which is 7. So the volume of this box, 1 times 1 times 7, is 7 cubic feet. Okay, so that's one design. Let's look at design number 2. Again, the top, front, and back are all congruent rectangles. The ends are still squares, and again, the gray section is waste. We don't want very much waste. That got smaller this time, didn't it? Now look at our figure. It says 5x equals, so you're looking somewhere for 5 x's. Here's 5 x's right here. All of those x's together, which would be 5x, it tells me is 8 feet. So I can write that equation as 5x equals 8. So to solve for x, I would just divide both sides by 5 to find out that my x is 1.6. Exactly, it's a terminating decimal, we're not rounding. Okay, so if x is 1.6, my length and my width of my base are both 1.6. The height of the rectangle is already given as 4 feet. So my volume at length times width times height gives me 10.24 cubic feet. Okay, so far, remember, we're trying to find the maximum possible volume. Design 1 had 7 cubic feet. Design 2 had 10.24 cubic feet, so it's better. Now let's look at design 3. The top, bottom, front, and back again are congruent rectangles. Here they are. The ends again are squares. See, the length and width are the same. They're both x. These are our ends. There's no waste in this design, so that's a really good thing. So look at our figure. It says 2x equals what? So look here for 2 x's. Here's 2 x's right here. I'm told on the opposite side that that's 4 feet. So 2x equals 4. So I can solve for x by dividing both sides by 2 and get x equals 2 feet. So I know the length and width part of my volume. I need to find the height part, which is given as 8 minus x divided by 2. Well, if I know my x is 2, then I have 8 minus 2, which is 6, and 6 divided by 2 is 3. So the 8 minus x over 2 part is 3. 3 plus 3 plus 2 gives me this whole side, which is 8. The 8 minus x divided by 2 is the height, because remember, this is going to fold up to the base. This is the length and width, so this is the height of the rectangle, which is 3. So the volume is 2 times 3, which is 12 cubic feet. Now, I haven't been writing all this in, but all of these are feet, by the way. That's how we're getting cubic feet for the volume. So, based on the designs, the maximum possible volume appears to be which design? Design number 3 that had 12 cubic feet. The one that had no waste had the most volume. Now that's it for our examples, but I had wanted to review something, a skill from algebra that you're going to need from your homework, and this was on your summer packet. It's solving literal equations. It's when you're given a formula and you manipulate it to solve for one of the variables in the problem. So if I gave you the volume of a rectangular prism, we all know that is V equals LWH, length times width times height. Remember, formulas are always equations. So if I asked you to solve for W, we would want to get rid of the L and the H. What operation is going on between those three variables? Multiplication. What undoes multiplication? Division. So I would divide to get rid of the L and H. And what I do to one side, I have to do to the other. Exactly the same thing. So we know a number divided by itself is just 1. So L divided by L cancels. H divided by H cancels. I have W by itself, and it is equal to the volume divided by the length times the height. Now, on one of your homework problems, you're going to get a messy equation like this. And if you want to solve for x, you're doing what is called factoring. So you look on this side of the equation, and both of these terms have an x. So I can factor out the x and put what's left over inside the parentheses. X times what is 2x? When I take that x away, a 2 is left. When I take this x away, I have a negative 3 square roots of 5 left. So all I did was factor out the x. Now I only have one x in the problem instead of 2. So now if I want to solve for x, I need to undo the multiplication between it and this binomial. And what undoes multiplication? Division does. So I'm going to divide by this 2 minus 3 square roots of 5 that's being multiplied by my x. And I have to do the same thing to both sides. So this 2 minus 3 square roots of 5 cancels with this 2 minus 3 square roots of 5. So if I want to know what x equals, I can put this in my calculator and round to whatever I want. Now what you need to be careful about is you can't put in 12 divided by 2 minus 3 square roots of 5 in your calculator like this. All your calculator is going to divide by is 12 by 2. Get that answer, which is 6, and then subtract 3 root 5 from it. So since you want the 12 divided by that whole denominator, you've got to do in your calculator 12 divided by, and in parentheses, 2 minus 3 root 5. Get out of the radical and close that parentheses. Now my calculator knows to divide 12 by that entire number. Okay, so whatever I was rounding to, that would be to the nearest tenth, negative 2.5. Good timing, the lights just went off. But there's a couple of things I want to talk about with your homework, so just a moment. Okay, so now let's look at your homework. I already told you on number 1, you want to refer to example 1, round your answer to the nearest tenth, but not until the end. Number 2, for part A, you need to use the variables that are given in the problem. It tells you to use L for the length, M for the amount of material, which is the surface area. It tells you what variables to use, X and X for the length that's in the whole problem. So you're going to be using X's, L's, and M's in that equation. Part B, you're going to be solving a literal equation just like we practiced right here, solving a literal equation. Part C, you're using substitution. So you're going to substitute the expression for L in the expression for M for part A. So whatever you get for L here, you're going to replace the L in part A with that, and that's what you're putting here. On part D, it gives you all the same directions that we did on number 1, and I gave you the correct window to use. So when it says in a suitable viewing window, this is the one that you're using. On part 3, or number 3, part A, you want to solve both of these constraints for R. So this constraint right here is why I just practiced this with you on how to solve for X when you have 2 X's. You have 2 R's, so you want to do the same thing. So solve for R on both of those constraints, and then your answer for your radius, the greatest value of R, would be the largest number that satisfies both of these constraints. On part B, use your value that you find for R in part A to find the height of this cylinder. Okay, so 2 pi R, remember that's going around the circumference, that's not the height of the cylinder. This is the height of the cylinder, which is 4r. So if you know what r is, you know what 4r is. And then you're going to find the volume of the cylinder. Volume equals pi r squared h. So hope this helps. I can't speak, but I hope this helps.